AP will provide you a standardized table of cumulative relative frequencies under the normal curve below any given z-score. Recall z-scores show where you are located on the x-axis in terms of standard deviations from the mean. Every truly normally distributed distribution of scores have these proportions associated with how many standard deviations a score is from the mean. Therefore, by converting a score in any normal distribution to a standardized score, a z-score, we're able to use this table to determine proportions and probabilities for all normal distributions. Suppose we are again considering heights of women, with a mean of 65 inches and a standard deviation of 2.5 inches. If we convert the height of 62.5 inches to a z-score, the z-score must be -1 since 62.5 inches is exactly one standard deviation below the mean of 65. Looking at the standardized z-table, we can conclude that 0.1587 women have heights below 62.5 inches. Find the probability of a height randomly selected being greater than or equal to 70 inches. 70 is exactly 2 standard deviations above the mean. This is a z-score of 2. The table shows 0.9772 below 2 standard deviations. Therefore, 2.28% of women are at least 70 inches tall. We studied transformations earlier. Here's the transformation formula to convert a score from any non-standard normal distribution into a standardized z-score. Standardized because z-scores belong to the standard normal distribution with a mean of 0 and standard deviation of 1. Z is equal to x minus mu divided by sigma. Looking at our example of heights above 70 inches, z is equal to 70 minus 65 divided by 2.5. 70 minus 65 yields a difference of 5 inches, meaning that 70 is 5 inches to the right of the mean. A z-score tells us how many standard deviations from the mean we are. This is why the difference of 5 inches is divided by the standard deviation of 2.5 inches. This tells us that 5 inches is exactly 2 standard deviations right of the mean. Hence, z is equal to 2. Find the probability of a randomly selected woman's height being above 62.2 inches. Convert to a z-score. Use the standard table to find the proportion below. Subtract from 1 to find the proportion above, and we find that roughly 87% of women are taller than 62.2 inches. If a woman is randomly selected, find the probability of her height being between 64 and 65.5 inches. Visually, we are looking for the area under the curve between 64 and 65.5 inches. AP would love to see us reference z-scores in our work to establish we understand how to calculate such a proportion. Step 1, the z-score for both endpoints of the interval. Step 2, the areas, proportions below each z-score. Subtract them to find the proportion within the interval. AP insists that you are able to justify your answers in order to earn the maximum number of points. Be in the habit of showing work to find z-scores and indicating we want the proportions in between or below or above, like we see here.